All right, this is the next unit in geometry. It's unit 7. It's called quadrilaterals. Okay, a quadrilateral is a four-sided figure. So that's what we're going to focus on in general for this unit. Quadrilaterals, four-sided figures. Okay, but today's lesson we're going to focus on polygons and angles of polygons. Okay, that's the first lesson. Okay, so this first definition, and we've talked about this before. I believe we talked about it in the similarity and congruence units. This first definition is polygon. Polygon. A polygon is a closed figure whose sides are all segments. So no curves, no openings. The sides of each angle in a polygon are called sides of the polygon, and the vertex of each angle is a vertex of the polygon. Okay, so here we go. A polygon is a closed figure formed by finite number of coplanar segments such that the sides have a common endpoint are non-collinear. The sides that have a common endpoint are non-collinear, and each side intersects exactly two other sides, but only at their endpoints. A polygon is named by the letters of its vertices written in consecutive order. So for example, polygon ABC or polygon WXYZ, okay? Just go in order when you name them, WXYZ. Don't do WYZX, okay? Don't do that. Go in order. WXYZ or YZ or WZYX, for example. Okay, just go in order, don't skip around. Or polygon EFGHJK. Don't skip around. Don't do EGHFJK. Go in order. Okay. And these are non-examples of polygons. Okay. This one, there's an opening. Okay. This one is a curve. And these overlap. Okay. Okay, there's two types of polygons. Polygons can be either convex or concave. Convex or concave. Suppose the line containing each side is drawn. If any of the lines contain any point in the interior of the polygon, then it is concave. Otherwise, it is convex. So if you look at this, let's start with this one, okay? So suppose we take this side and we draw a line through it. Well, some of the line passes through the interior of the polygon, therefore it is concave, okay? Same thing with this side, okay? If you draw a line through this side, it goes through the interior of the polygon, so it's concave. As opposed to this polygon right here, where if you draw a line containing each side, like this line, or this line, or this line, this line, this line, there's no points of the lines in the interior of the polygon. Therefore, that one is convex, okay? So that's the difference between concave and convex. You are already familiar with many polygon names such as triangle, square, rectangle, etc. In general, polygons can be classified by the number of sides they have. So in general, a polygon with n sides is called an n-gon, okay? But the common types of polygons you're not going to name n-gon. You're going to see in the table below, okay? We have some common names for different polygons. Now, a convex polygon in which all the sides are congruent and all the angles are congruent is called a regular polygon. Okay, that's a convex polygon. A convex polygon in which all the sides are congruent and all the angles are congruent. That's a regular polygon, okay? Here are some common names of polygons. You should know that 3 sides is called a triangle. 4 sides is called a quadrilateral. Like I mentioned earlier, that's the name of the unit. So this unit is basically going to be all on quadrilaterals going forward. Maybe after today, we're really going to focus on just quadrilaterals. That's the name of the unit. But today we're doing different types of polygons, as you'll see in this table. Okay, 5 sides called a pentagon. That one's you're probably familiar with that one. Okay, 6 sides the hexagon. You're probably familiar with that one. 7 sides you probably haven't heard as much. That's called a heptagon. Heptagon. 8 sides you probably heard a lot. That's an octagon. 9 you might not have heard as much. Nonagon. 10 you might have heard. Decagon. 11 is not very common. 12 we have in the table. Dodecagon. And any other ones that aren't in the table, you can refer to as an n-gon, because we don't hear those names too much. Okay. All right. So this next theorem here is very important. You may hear this a lot. Called the interior angle sum theorem. It says, if a convex polygon has n sides and S is the sum of the measures of its interior angles, then S equals 180 times n minus 2. Now that should make sense. So let's think about that for a little bit. Okay. Let's talk about triangles. We've done a lot with triangles this year. Okay. So let's focus on triangles. All right, let's focus on triangles because we've done a lot of those this year. Okay. So if I draw a triangle, I think you all know what the angles add up to, okay? So, but this one has 3 sides, so n would be 3 in this case. So according to the formula, S, the sum of the interior angles, equals 180 times n minus 2. So 3 minus 2. That's 3 minus 2 is 1. 180 times 1 is 180, like we've done all year long. Let's look at one more example. Let's look at a quadrilateral, because that's the name of the unit. And this one you probably know, but let's do a rectangle. It's a bad drawing, but you should know all these angles are 90, and you should know that they add to 360. Okay, the angles in any quadrilateral always add to 180. The interior angles, I should say. So in this case, n equals 4 because there's 4 sides. So according to the formula above, S equals 180 times n minus 2, so times 4 minus 2. 4 minus 2 is 2. And 180 times 2 is 360. So it should make sense. Okay, so that just shows you why it's true. I mean, you probably already know those two. That's why we did those just now on the side. But for any polygon, to find the measure of the interior angles, which is denoted with an S in this case, you do 180 times n minus 2, where n is the number of sides. Let's do one example on that. The regular polygon below is the base of a fish tank. Find the sum of the measures of the interior angles of the polygon. Okay. Well, since it's a fish tank and it's a pentagon, it has nothing to do with the fish tank. We don't care about that. There's 5 sides, 1, 2, 3, 4, 5. I'll just jot down that n equals 5, just so you know. N equals 5. Now let's go back into the formula that I just gave you. S equals 180 times n minus 2. You may be able to do these in your head, but I'll just do it out now for the notes. So S equals 180 times 5 minus 2. So 180 times 3, which is 540. Okay. That shouldn't be too bad. Okay, this next problem is a little trickier. It's kind of like a working backwards problem. The measure of an interior angle of a regular polygon is 108. Find the number of sides in the polygon. Okay. So let me start with this formula down here. Okay, let me just copy that formula down first. S equals 180 times n minus 2. Now, each interior angle is 108. So what I'm going to do is I'm going to replace the S with 108 times n. N would stand for the number of sides. We don't know how many sides there are, but S is all the sides. S is all of the sides. We know each one is 108, but we don't know how many sides there are. So this is the equation that we're going to use to solve for n, the number of sides. Distribute 180n minus 360. Subtract 180n on each side. You get negative 72n equals negative 360. And then when you divide, you get n equals 5. Okay. That was a tough one. So yeah, that's a good, I like that problem. That's a working backwards problem. A lot of people might forget to put that in there, but that's how you do it. Example 3, find the measure of each angle. Well, if you don't know right away that they all add to 360 because it's the quadrilateral, you would have to do 4. You'd have to go back into this formula. 4 sides, so 4 minus 2 is 2, times 180 is 360, but all of them should add to 360. You might know that one already. And any quadrilateral, they add to 360, so that one you probably have memorized. But if not, you would do 4 minus 2 times 180. 4 minus 2 is 2, times 180 is 360. Solve that for x and then find the angle, so 6x equals 360. X equals 60, which is great, but now just find out each angle. So the measure of angle A, measure of angle B, measure of angle C, and the measure of angle D. A is x, which is just 60. B is 2 times x, which is 120. 120 for C, and 60 for D. Last page. Oh boy. A little more difficult now. Find the measure of each angle. All right. So first, let's figure out what all the angles should add up to. Okay? Because this one you might not have memorized. Or maybe you do. Let me just write that a little nicer. Okay, since space is limited, I'm just gonna tell you what the answer is. N minus 2 is 5 sides. 1, 2, 3, 4. 5 sides. 5 minus 2 is 3 times 180 is 540. All these angles should add to 540. So let's add them all up and say they equal 540. Then we can find each angle. X plus 20 plus x plus 5 plus x minus 5 plus x plus 10 equals 540. So combined like terms, 5x plus 30 equals 540. Let me just double check that. Yeah, okay. 5x equals 110. Or 510 actually. Let me make that nicer in a second. X equals 102. Okay, so x equals 510. Okay. 5x equals 510, x equals 102. Now let's find each angle. Let's go in order. Just like the last one, measure of angle E, measure of angle F, measure of angle G, measure of angle H, and measure of angle J. So E is just x, which is 102. F add 20, so 122. G add 5, 107. H subtract 5, 97. And then J add 10, it's 112. Okay. All right. One more theorem and then one more example. The exterior angle sum theorem. Think back to when we did parallel lines. Exterior angles were angles outside parallel lines. Exterior angles would be the angles that you get when you extend a segment. So if we focus on this pentagon right here, we have 5 exterior angles. That's an exterior angle when you extend the side. That's an exterior angle when you extend the side. That's an exterior angle when you extend the side. That's an exterior angle, and that's an exterior angle. Okay, so if a polygon is convex, then the sum of the measures of the exterior angles, one at each vertex, is 360. That's the theorem. Example 5. Find the measures of an exterior angle and an interior angle of convex regular octagon ABCDEFGH. Okay, so since it's a regular octagon, every exterior angle will be the same and every interior angle will be the same. So let's start by finding the exterior angles. There's 8 of them. So I'm going to say 8x equals 360 because of this theorem right here. All of them have to add to 360. Okay, so if I do 360 divided by 8, that gives me 45. So those are the exterior angles. Exterior, 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 exterior. Okay, those are the exterior angles. Exterior, 1, 2, 3, 4, 5, 6, 7, 8. How are we going to find an interior angle? Let's focus on A. We know this one. The one with the angle at 2 arcs, the exterior angle, that's 45. How can we find the interior angle? There's a bunch of ways you could do it, but they form a linear pair, so they have to add to 180. So I'm just going to say, I guess I'll do y this time because I just used x. Let's say 45 plus y equals 180. So y would equal 135. So again, this was the exterior angle, and this is the interior angle. I'm going to say each exterior angle is 45 degrees. And I'll say each interior angle is 135 degrees. Okay. All right. So that was the beginning of Unit 7. Unit 7 is called quadrilaterals. So going forward, we're going to focus only on quadrilaterals, which are 4-sided polygons. But this lesson was not just quadrilaterals. This lesson was polygons in general and different angles of polygons.